All right, folks, welcome back to Mike and Maurice's Mind Escape. We have episode number 135 today. We're going to be talking about the tidal forces and our solar system with Chris Cottrell. He's back. He runs Dabbler's Den, which is a channel on YouTube. Go check him out. I have the links down below the video. And welcome back, Chris. How are you?
Thanks, guys. It's good to be back. It's been almost a year since we met up last time. And there's been quite a bit in the younger Dryas field that's gone on since then. So
nice.
It's good to catch back up with you guys.
Awesome. Yeah, I know. I try and keep up. I follow your channel. I try and keep up with Cosmographia and the Brothers of the Serpent and all the different podcasts and stuff. But Why don't you give us a little bit of an update on what's happened since we had you on?
Well, it's kind of interesting. I've got a book here. Title, I don't know if you can see it, titled Deadly Voyage, the Ancient Common Strike That Changed the Earth and Human History. This little book right here, it's not very long. This has changed quite a bit in that whole younger Dryas field. You guys, the last time we talked, I think we mentioned guys like Michael Shermer and Mark DeFont, who have been like longtime skeptics of this, and they're the ones that went on Joe Rogan and, had debates with Grant Hancock and Randall Carlson. And, just in the past few weeks, they've both come out I wouldn't quite say in support of the younger Dryas, but they have come out to say that, hey, there's enough evidence here that we really need to start looking at it a little closer. And that's all we've been asking. You know what I mean? So
do you think I've got a question? So it seems like, with you and like George Howard and everybody that's involved in pushing this, there's another guy I follow on Twitter too, who does this stuff. I think his name's Mark something.
Mark.
Yeah. And, you guys have all been pushing for academia, but is it necessary? I mean, you have a degree in geology and stuff. Is it necessary for those people to get on board, or couldn't you just be, the top dogs in this niche, or what do you think needs to happen?
Those are the guys that write the papers. I have a master's degree in geoscience that I use for education. I think we talked last time, and, I'm a high school science teacher. That's what I do. That's what I enjoy taking complicated science topics and breaking it down, so that a 17 and 18-year-old kid can understand. And that's really what I've been trying to do with the channel, and everything that has to do with the younger Dryas is just take those topics and break them down so that other people can understand them. So that's that's my job. But it's the guys that are in the scientific field, the academic science community that are writing the papers. They don't care about us. There are some that have no idea that there's this like underground movement trying to push the younger Dryas narrative. And, so to have people like Michael Shermer and Mark DeFont to come out and actually say that, hey, they're building a really strong case for this, we all need to start paying attention. That's just huge. That's a really big push in the right direction. And I don't think it'll be long. When you have a big time a skeptic, when you have a big time, all it takes is one. If you have a group of people that aren't quite sure, all it takes is that one skeptic to come out and say, oh, no, this is bunk. And everybody else is like, oh yeah, okay. So we don't have to waste our time on it anymore. Yeah. And so to have guys like that to come out and actually come out, and say what they said, that's just a big push in the right direction. So.
Yeah, absolutely. And the other thing I wanted to ask you about too is, so, I mean, you made a good point about people not even really knowing what's going on. I was on Discord on a completely different subject. I think I was talking to somebody on like a psychedelic forum, and he was a geologist, and he was talking about, we were talking about this kind of stuff. He's like, yeah, I don't really know that much, because you either go into oil or you become like an academic, is kind of what he was getting at. And he was saying, he was mentioning, and I said, well, what about this and what about that? He's like, I'd have to look into it. But I'm like, there's a war on these topics going on, and most scientists don't even realize it. And I think if some of them did, they would probably agree with some of the data and evidence. So, but what do you think about that in terms of geology and geosciences and stuff like that? Is that true that some people either just go into like the oil industry or some become teachers?
Yeah.
Or
Yeah. I actually spend my summers over on Sapelo Island. The University of Georgia has a marine institute over there. And so I spend, about 2 weeks of my summertime helping out and communicating with PhD students that are working on their graduate degrees. They're so focused on those certain things, whatever their topic happens to be, they're so focused on that, that sometimes they just miss that big picture. Right. And we talked about this last time where, being a generalist, and that's, again, my job is to take complicated science topics and break them down. That makes me a generalist. That makes me a person that can kind of see the big picture, take a little bit from this part over here and a little bit from this part, and build that big picture and connect those dots, that a lot of people just don't, if you're that focused and that centered on whatever your topic happens to be in academia, then it goes right over, they just miss it. And so it takes people like Mark DeFont, who is a geologist. He works for, I think, Central Florida University. He's a geologist. He's in academia, and it's so to take guys like that, to actually say, whoa, hey, they're building a really strong case. Let's take a step back with this skepticism and actually give it a fair chance. And that's, like I said, that's all we've been asking. So I think it's a really big step in the right direction.
So since we talked to Graham Hancock's newest book came out, America Before. A lot of it had to do with that. I mean, he talks about George Howard and Mark. That
had actually just come out before we had our conversation. We actually talked about the book.
I don't remember. I didn't go back and listen. I only listen when I edit sometimes. But
you guys you got to get on the bandwagon, brother.
Yeah.
I mean, who is the dude that's sitting there listening to his own podcast 100 hours a week? I'd like to know that person.
That's a narcissist.
Well, listen, all I'll say is that, however many views I have on my YouTube channel, I'd say about 80% are just me checking it. So
Same.
Well, I mean, I think, we're all guilty. We want to know what's going on, but I don't sit there but now that you say that actually, that would make sense that came out then. But all those we did. Now that I do remember actually us talking a little bit about that. So, what other evidence has come up since then? Is there any, besides the academics kind of getting on board, is there any, I know there's been some craters, but they don't really know what's going on yet.
Yeah, the stuff that came out, I think one of the big pushes was the Abu Herrera stuff. Mm-hmm. Did you follow that?
A little bit.
Where they're picking up like a lot of proxies from those areas. And I don't, George Howard knows all. He actually went and helped dig on that site a few years back. And so he's really big on that. But they did go back, and because that site's been being dug for, I can't remember. I think that it was dammed. I think it's underwater now. Mm-hmm. But they were able to, get enough collections back in the 70s that they were able to use that to check for proxies. And they were like, holy crap, look at all the stuff that we're finding now. Now that we know what to look for, and so that was a big step too.
Sure.
So that, that's come out, and there's been papers left and right. You just mentioned Mark Young. He's been the one kind of keeping that whole bibliography up to date, on the cosmic tusk. Mm-hmm. And he's constantly adding things, every few months there's something else that comes out that's in support of the Younger Dryas. And again, that's why Michael Shermer and Mark DeFont had, kind of reevaluated things, which I mean, that is huge. These guys were big skeptics. And to have them come out who have been publicly being publicly skeptics of the whole thing.
Right.
They're finally saying, okay, the evidence is building, and we're starting to see the picture now. So again,
there's even people outside of geology that have been weighing in, though. I know I saw there was some guy on Twitter. He was an academic, and he kept going after a lot of the, like the Graham Hancock stuff and all that, trying to, I forget his name, Hooper maybe, or Hoops, something like that.
Yeah.
And he's not, I think he's an archaeologist. He's not even a geologist or anything.
Yeah, from like the University of Kentucky or something like that. Yeah. Actually, listen, he's actually the guy who kind of oversees the Younger Dryas wiki page. And that's like the problem. And it's like, this guy is the one who helps maintain that site.
Right.
And so he gets to pick and choose what gets, submitted to that site. And that is, I mean, if you can see the problem in peer review, that's it right there.
The logic.
I'm not familiar with that. What's going on? Is that thing just a mess, or?
You'll have to get Mark on. He had a long and drawn out Twitter debate with him one day. But yeah, he's definitely against the Younger Dryas being an impact related event. And so anything that comes out that points in that direction, he pushes it away from that wiki page. Because it is a public page, people submit things, and then there's somebody who goes along and decides whether it can stick or not, and he's that guy for the Younger Dryas wiki page, and it's just like, how does that happen?
Yeah.
So,
I know I'm kind of a watcher too. If the watcher's listening, I don't know if he is, but
I hope he is. I sent him a text and told him that we were going to be meeting tonight. He's awesome. He's like kind of the glue that he's got his hands in everything. He's very appreciated on my end, that's for sure.
Yeah, but I do the same kind of thing. I watch. I don't really. If something's egregious towards what I'm doing or something, I'll address it. But I'm not on Twitter to interact like that with people or anything like that. But I just watch what's going on, and that one guy, though, it's interesting because the way he attacks people isn't even based on data and evidence. It's more along like, oh, Graham Hancock wrote a book about the end of the world in 2012, and he keeps going back to that. He keeps repeating old stuff as if people don't evolve and grow and change their points of view.
Atlantis and things like that, just because he knows that it's kind of on the other side of that pseudoscience thing, and so they're he's like, oh, what about this and what about that, and it's not fair, so let the science
I felt
happen.
good about what I know as far as knowledge and philosophy and stuff like that based on what he was saying. So, and if he's an academic,
a real turd.
Yeah.
All right, so let's get to what we're here for now. Yeah.
In true Dabbler's fashion, we'll talk about something that is completely unrelated to what we've just been talking about.
No, it's good to have a little banter before we get going. But so we're going to do the slideshow that you prepared. You have done a video on this on your channel with some moving GIFs and graphics and stuff like that. So this one won't have all the moving bells and whistles, but we'll have all the general data. But if you want to watch the real thing, you can go on to Chris's channel, Dabbler's Den, and check that out after we're done here. So why don't you give us a little bit of background on what we're about to be talking about here?
All right. So the background on this, it was last summer about this time of year. There was a rash of tectonic activity all around the planet. There were volcanic eruptions and earthquakes and things like that. And it just seemed to be, I don't know if you guys remember or not, but seemed like last summer there was something, every few weeks something big was happening. Mm-hmm. And I thought about that, and then it kind of went away. It wasn't something I really thought much more about. And then come December, we started to see another rash of tectonic activity around the planet, where it was just picking up. We saw a couple extra volcanic eruptions. I have some examples there, like the White Island, which is actually recently in the news because some of the cruise passengers are suing Carnival or something because of getting burned from that actual eruption. But that was back in December. Kilauea became much more active, even though it's been constantly erupting anyways. Became much more active. However you say, is it Tidal in the Philippines, that erupted again in January. And so I started noticing that there was this pattern, like every 6 months or so, we saw an increase, or we are seeing an increase in the tectonic activity. And so I started to do a little research on it, and I was wondering how tectonic forces or tidal forces in the solar system could be affecting this. And it was just a thought, it was like, I wonder, where are the planets right now? Why is this happening right now? And so there's actually a website, and we'll look at a few of these images as we go through this, because there's a website called The Planets Today. And anybody can go on there, you can look it up, and it will show you where we are in relation to the other planets in the solar system. And it just so happened that Jupiter and Saturn were really close to each other. And I thought that was very peculiar. And so that's what kind of set it off. And we'll talk a little bit more about that as we get into it. But yeah, it was really because I started noticing this like 6-month pattern of recent tectonic activity occurring. And then it would kind of go away, and then it would come back. And so that's what kind of started it.
Yeah, and actually, I tagged you in the super volcano episode we did. Couple, and
that's actually why I it kind of fits in. It's not quite related to what you guys are talking about with Yellowstone,
right?
But just the fact that you're interested in the tectonics, I thought was like, hey, let's talk about this, because this could definitely play a part.
Well, part of that though was because what was happening, I think even you have, so there the last one looks like January 2020 of this year. I think it was March or April. There was 30 volcanoes erupting at the same time. There was a massive earthquake near Yellowstone in Idaho that was like 6.5 or 6.7 or something like that. People were tweeting all crazily, oh, Yellowstone's going to erupt. So that got me thinking, like, well, what is a warning sign for this if it were to actually occur? And a lot of these are millions of years old or hundreds of thousands of years old. So, like, what do we know what's going on? So that interested me into look into it. And obviously I'm not a geologist or a scientist, but I can read data and Wikipedia and different resources. So I was able to put together at least the mechanism for how some of these things operate. But
So that would be like another little nail there in that one, because I do think that there's a lot more going on geologically than we're quite aware of, and it's because we're part of a system that's much bigger. We're part of that. The solar system is much bigger, and so all these little parts play their own role. And I think we're just now kind of starting to understand that. And I've got some good examples, and we'll get to them here in just a minute, so I don't want to kind of spoil it yet.
Okay. But I'll point out to anybody that's listening to this on an audio platform, we are about to start a slideshow. So if you haven't checked out our YouTube channel, check it out. Also check out Chris's. And let's get going here. You want me to hit the next slide?
Yeah, go ahead. It's kind of the same. It's just an update. Since we talked, like I said, the presentation I made was back in January. It was the end of January, and again, I was like, well, there's some stuff going on here. Let's take a look at it. And I kind of made some bold predictions back in January, and now I'm kind of following up on that, and we'll see where we're at. To be honest, I don't know where we're going to be with it,
Right.
But we're definitely kind of approaching those predictions that I was talking about. And again, we'll talk about. So this is recent. This is over the past week, June 2020. If you're listening to this at a later date, this is right now is June, the end of June. And if you'll notice, there's been a couple eruptions that have happened. Nothing really major, nothing super big. There was a big volcanic eruption in Indonesia last week, and I think it's. I'm going to murder these volcano names, but I think it's Merapi in Java. There was a Russian volcano that erupted that I think is part of the Aleutian Island chain, and that was a little bit earlier in June. But again, these are all within the past few weeks. But it's the volcanic. The earthquake activity that has occurred too over the past few weeks that has really kind of caught my eye. Because remember, these tectonic forces aren't just volcanic eruptions. We have a mix of earthquakes and volcanoes, and I think that they're related to the tidal stresses that our planet is seeing right now.
I was going to ask you too, real quick, about the study I think they were doing when everybody was on lockdown. Some geologists did a study, and they found that there was, I forget if it was, I know this is going to sound stupid, but either more or less seismic activity because there isn't people all out and about driving and walking, and it made sense when I was reading the thing too. I'm like, that actually kind of makes sense. I didn't know if you saw that study.
I did see the study, and that's just another great example of how out of touch academia can be sometimes.
Okay.
It's so one-sided sometimes. But no, I really, once we get done today, I think you may have a better idea of what's actually going on.
Okay.
Because this is kind of, like I said, this is all happening over 6-month periods. And I'll explain why, but this is all happening over 6-month periods, and we're kind of in the middle of one of these things right now. So anyway, so on the slide right now, like I said, we've got a couple recent earthquakes. Down in Mexico, there was 7.4. Anything 7 and above is going to be, that's drastic. But there have been a couple other, just in the past week or so, some 5 point somethings earthquakes that have gone on in Owens Valley. There was a big rock slide in California. Again, this is nothing that's not unheard of. I mean, these things happen all the time. We have earthquakes, we have volcanic eruptions and things like that. And I definitely don't want to come off as, Chicken Little-ish here, where the sky is falling, but I do think that we're going to see an increase in volcanic activity. And the reason why that's important, and this has a lot to do with, it's kind of how I can tie it into the Younger Dryas, is because, what's that?
No, he's getting a call, so that's cool.
Yeah, it's History Shift texting me.
If you're listening, History, stop texting.
Yeah. He's on. Anyway, so yeah, it doesn't take much to kind of to affect the climate. And I say this in my class all the time, and you talked about this too in your Yellowstone. Or no, I was actually after that. The guy you were talking about last time, your last episode, about how
with Arthur, the Viking and Norse mythology episode.
Yeah, you guys just were talking about supervolcanoes having the ability to affect climate.
And
drop. And it's not just supervolcanoes. I think when Mount St. Helens erupted, we saw a drop in global temperatures by like 2 degrees. And I always say this in my class, 2 degrees Celsius. And I always say this in my class, well, what would happen if we had like 10 of these, Mount St. Helen type eruptions happening at one time? That could literally put us back into an ice age. And so it does kind of tie in to the whole climate of the Earth conversation anyways. So again, I don't want to like come off as, this is the end of the world kind of stuff. But I do think that we are going to see an increase in tectonic activity over the next couple weeks.
Yeah,
it's weeks, not even months. Huh?
Yeah,
seriously.
Is it so? Is it?
We're writing this down, baby.
More active in the summertime, then? Is this what you're saying?
Let's go ahead. Go to the next slide, and we'll get into the reasoning why here.
Okay.
So the first thing I wanted to go ahead and talk about was what tidal forces are to begin with. Tidal forces, this is nothing new to our planet. This has been going on for a long time. We know that gravitational masses can affect us here on planet Earth, and it happens daily. It happens every single day. Our closest gravitational mass is the moon, right?
Right.
And it's not that far away. It is a big chunk of stuff up there in the sky. And it's the gravitational mass is pulling on us just as much as we're pulling on it and keeping it in our orbit. But as it's pulling, mass from the Earth, it actually can lift stuff that's not quite connected to the planet, like ocean water. And so the gravitational pull from the moon actually lifts a bulge of ocean water towards it as the moon is moving around the planet. It takes the moon 30 some odd days to go all the way around the planet once, but the Earth is also spinning underneath the moon 24 hours a day, so it's spinning all the time, but there's that constant pull from the moon. And that's what gives us our tides. And we actually have 2 tides a day. Where I live in coastal Georgia. We have 8-foot tides where you literally, if you go out at low tide and, you're in knee deep mucky mud, and 6 hours later, the water will be over your head. It'll be 8 feet higher than it was 6 hours ago. And that happens twice a day. You have 2 high tides and 2 low tides every single day. And that's just gravitational pull from the moon. I'm not even sure, like, because I know that the Great Lakes, you guys are up in Michigan area, you're probably a little more familiar with the Great Lakes. They have tides too. It's not quite as dramatic as it is down here in the South.
Some of the deep channels will get you. You have to be careful.
Well, yeah, I know that I've got a couple pictures on this slide here of the Bay of Fundy or Funday. It's up in Nova Scotia, where I mean those tides are super dramatic. I can't remember exactly how big those tides are. Maybe we can get History Shift to check on the tides of the Bay of Fundy.
Ooh, History Shift,
our go-to guy.
Throwing some loot around. We love you, History.
But they're huge tides. So we know that we have these gravitational pulls from objects that are in our solar system. I mean, the moon is right there. It's in our solar system, and it is pulling on us. It does cause an effect on objects or masses on our planet. So yeah, I mean that's a proven thing. It's not like we're making stuff up with that one.
Right.
Anyways, you got any questions about just tides? It is kind of complicated.
But the reason why and correct me if I'm wrong, but we're all hurtling through space at like a corkscrew projection, right? Like we're obviously not still, our solar system in space. So therefore everything's in constant flux and motion, and it's all being held together. And what you're saying is when the moon and the earth are pulling on each other, it creates this bulge where the force is that what you're saying? And then it moves the tide around? Is that what's going on? Or
the force is holding that bulge there. It's
right.
Holding the mass that's not directly connected to the planet towards it.
Okay.
The ocean water is a fluid, so it's going to be affected by that gravitational pull. And so as the Earth is rotating under the moon, like this is where some of the GIFs kind of would have been beneficial, because that GIF actually shows the rotation of the Earth, and not only did it show that, but it also shows one full day of arc motion of the moon. Because remember, the moon is also moving around us at the same time that we're spinning, so there's a lot of different forces happening. But bottom line is that we do have tidal forces from gravitational objects, gravitational masses in our solar system, and that's just a very basic one. And it's not the only one either. If you click to the next slide, there's another gravitational mass that affects us almost, not quite as much, but almost as equal, and that's the sun. The sun is much more massive than the moon, but it's also much farther away.
Right.
So believe it or not, the gravitational pull from the sun, the gravitational force from the sun affects our tides. It does pull the ocean water towards it. And we know this because as we're spinning and the moon is going around us, anytime that we have a new moon or a full moon, those gravitational forces align and they strengthen. And so during a new moon, you can see in the pictures there, we have this huge gravitational force, this huge mass, the sun. Then we have the moon in between the Earth, and that's going to cause just a little bit of an extra tug, of the ocean water. And we can measure that. This is something that we can actually see because we actually have spring tides during new moons and during full moons. And that's where, if I mentioned here in coastal Georgia, we have 8-foot tides. Well, during a couple days, out of the month, which, by the way, month, that stands, that's a moon phase. That's a moon cycle of the moon. But there's a couple days out of the month where those things line up, and we get about an extra foot or so of high tide and an extra foot or so of low tide, and we call those spring tides. We call that a spring tide, where there's just a little bit of an extra tug from the sun and the moon aligning, where the high tide is just a little bit lower. I'm sorry, the high tide is just a little bit higher, and the low tide is just a little bit lower. And again, we can measure that, we can see that, and I own a boat. I go out boating all the time. I can tell anytime I go out during a high tide, the currents are much faster, when the tides change. And so there's all kinds of different ways that it affects us on our planet.
Yeah, we grew up on the water too. I mean, not on the ocean, but yeah, it's interesting. My quick question is, so the moon or the sun just accentuates or embellishes what the moon's already doing? Is that kind of what I'm getting at here?
Yeah, because of the alignment of those gravitational masses.
Okay.
That's right. So every month we have 2 spring tides. Once when we have a new moon, that's when the moon is between us and the sun, and you can't see the moon. The moon is out during the day. We can't see it because it's, the bright side of the moon is facing the sun.
Right.
And then on the other side, 15 days later would be a full moon, and that's because the moon is behind us, it's behind the Earth. So we have the sun, the Earth, and the moon, giving us that full big big bright full moon. Mm-hmm. But again, that just shows that we have an alignment going on there, and that can be measured and tested with those spring tides. Now, when it's first quarter moons or third quarter moons, where we only see half of the moon being illuminated, those are actually called neap tides, and those are the lowest high tides, and it's the lowest high tide and the lowest or the highest high tide. So it's the less difference in the actual tides that are happening during that time. So there's this weird tug of war between the moon and the sun that happens, every month. It happens. It's like clockwork. It's a cycle, right. And it happens, every time we have a full moon, every time we have a first quarter moon, every time we have every phase affects it that way.
And who doesn't enjoy a nice extra tug from time to time?
Yeah, right.
So there's a nice rhythm. That's the way I would describe it, is with our solar system and just everything working within it is just a rhythm, and we're really used to that rhythm. Yeah. But these little slight variants obviously affect us probably more than we know too.
Yes, and that's where I think for when we learn about this stuff, when we talk about this stuff, it's usually the moon. Yes, the sun affects us a couple times a month too, and then that's kind of it. But I think, like I said, I think there's more going on. We're part of a bigger system than just those 3 things, and we really should be paying more attention to what's going on in the rest of the solar system. And go ahead and click the next slide, and we'll see where we're at there.
Okay.
Well, first of all, the oceans aren't the only fluid spheres that we have on the Earth, right? Mm-hmm. We have these 70% of the planet is covered in ocean water, so that's going to be affected greatly by this gravitational pull from the moon and from the sun. But it's not the only fluid sphere that we have. It's not the only fluid masses that we have on planet Earth. As a matter of fact, most of the internal part of our planet is a fluid. It's molten magma and melted rock. And so, why would we think that that's not being affected by these gravitational tugs and these gravitational pulls, from the moon even? We'll talk later on because and there are some good papers out there that kind of tie the moon tides with volcanic eruptions. Mm-hmm. And it's something that I noticed over the past year of looking at this stuff, was that, normally when we have a big eruption, it's going to be during a full moon and a new moon.
So you think maybe that the moon is the gravity's pulling the magma up or something along those lines, or?
Yeah, or if anything, it's just fluxing it. It's causing changes. It's not.
I didn't mean pull it, but I mean, like crustal kind of, more of the separation on fault lines or that kind of stuff, which causes earthquakes and then more.
You can see in that picture there how thin the crust actually is.
Yeah, it's crazy.
And to kind of tie it in with your Yellowstone, that's what's going on there is you have a part of the mantle, which is, the mantle isn't really connected to the lithosphere. It's its own part in the structure of the planet. And so we have the crust, and then we have the asthenosphere, which is part of what we call the lithosphere. But it's hotspots are created when you have a very active part of the mantle, and it's actually melting the lithospheric crust above it, causing those big supervolcanoes like Hawaii, or the hotspot volcanoes like Hawaii or Yellowstone. But it just goes to show how thin the crust is, right? Because that's what volcanoes are. It's when the crust melts, that lithospheric melts. It's not really mantle material popping out of the crust. It's actually melted lithospheric material that's causing these things to happen. But anyways, yeah, it's, there's a lot more liquid mantle material than there is, solid crustal material. And so, they are affected by tidal forces as well.
I have a question. So how do we know, though, as far as what the layers are, how large they are? Obviously, you can use geometry and math to kind of deduct based on things we know for sure and core samples and different things. But then haven't we only gotten down to 300 feet or something like that?
I have a feeling that there's a couple really good secrets down there that we haven't quite dug out yet. Because we've only dug, our deepest mines have only scratched the surface of the crust. One of the things that they do is subsonic. I can't remember the name of it right now. It has to do with the seismic waves and how they can penetrate certain materials. Like some of them can only go through solid materials. Some of them bounce back off of liquid materials. I can't believe I can't remember the name of that right now. But that's one way that they do it. They actually, send in energy into the planet, and they're able to measure back, what they get back. They can deduct what's underneath them. I'll have to send you some more information on that later, though. I can't remember exactly. Yeah,
because I was talking to that same geologist I mentioned earlier, and they were saying, "Oh, they know, they figured it out." I'm like, "Well, how? What did they use? Like, point me to." And there was no information, so that's why.
Yeah. And like, I wish I could pull it up right now, but that's kind of deters from what we're talking about. But yeah, it definitely. That we have a good idea. But you're right. We've never been there. We've never actually dug down deep enough to get into the mantle or the core. A lot of the core is, supposedly has to do with our magnetic field. Where you have like a solid iron nickel core, and we have to have this molten core around it to give us that magnetic field. Again, that's beyond my pay grade. So, but
hey, I mean, it's fun to speculate here and there, though, on certain things.
Yeah, for sure.
Yeah, like I said, I have a feeling that there's a few surprises down there that we haven't even thought of yet. So,
I'm sure. To say that we know everything for certain, again, it just comes back to the same thing with everything. The minute you say this is how it is, 10 years from now, you're going to be wrong. 20 years, 100 years, it's going to be wrong.
That's what I was just talking about with my brother today. It's like 100 years ago, the science was one thing, and then 100 years from now, it'll be a completely different thing.
Yeah. Yep. So, anyways, all right, let's go on to the next one. Let's see.
All right. So this would be one of those moving GIFs, and it would show the way that the planets rotate around the sun.
I looked at changing this one anyways. It's just all I'm talking about here is that we have other gravitational masses in the solar system that we should be considering. You can see in the picture right there, and in the picture it just shows the different planets and how massive they are. And it always cracks me up where our units of measurement, they really only apply to us on Earth. Mm-hmm. But if you look at Earth, it's like one Earth mass, and we kind of look at everything else in the solar system based on one Earth mass.
Right.
But it does kind of help us a little bit, because we can actually see how much more massive planets like Jupiter and Saturn are compared to all the other planets. We have, the inner planets are tiny. They're like little pebbles that are floating around the sun. And then we have these like giant, massive gas planets like Jupiter, Saturn, Uranus, and Neptune. But that picture shows you how much more massive Jupiter and Saturn are compared to everything else in the solar system. Mm-hmm. And so this was one of the things that I wanted to look at. I wanted to see where those masses are in our solar system when we are having these increases in tectonic activity. And that's what surprised me. And if you go to the next slide, you'll see it a little bit better.
Okay. Didn't they always think Jupiter shielded us from asteroids and comets, but now they realize that it might be hurling them at us or something? I read an article about that like a year ago.
Yeah, it could do both. It could do both. It definitely protects us more because it is such a massive planet.
Right.
Again, I don't know why this would be so foreign because, we talk about the massiveness and how much gravity Jupiter has. And, it can literally, like we saw with Shoemaker-Levy, it could literally pull, comet chunks right into it. And this happens all the time, right? It's the big gravitational mass. It actually, there are moons around Jupiter that are so tidally affected by the mass of Jupiter that they crack and they spill out magma and stuff like that all the time.
Wow.
And yeah, I can't remember which ones. I think Jupiter has like 20 moons or something like that. And so, some of them, they just get fluxed over and over and over again. And it's just because of that gravitational pull, that tidal, it's actually called tidal forces. It's the tidal forces between the moon and that planet, and just cracks them and breaks them, and they reform all the time.
I think one of them has water or ice on them too. I think that is a Titan or one of them. Can't remember.
Yeah, Titan is a Saturn. It's a moon of Saturn.
Oh yeah, Europa. That's the one that's the one.
Yeah.
And there's a couple other ones on Jupiter. Io we're looking at. There's some really cool things going on there. I think we're going to find some really neat things once we actually get out there and deep dive into some of those moons. There's some really cool stuff going on around those planets. I heard a theory one time, and I don't know how much truth this is, but Jupiter almost became a second sun, and we would have been a binary solar system with two suns. I don't quote me on that. I know I'm going on.
Oh, you're on.
We're gonna hold you. You're on record.
Yeah.
This is on the record. No, I've heard that too. Like Planet X or Planet 10 or 9 now or whatever. If Pluto is or isn't, you never know. But something's pulling on the orbit of Neptune and Uranus.
Mm-hmm. Yep. There's something going on there, and that's actually how they first discovered Pluto, because there was something going on with Neptune, and they took a look, and hey, there's something, and it ended up being Pluto. Mm-hmm. But you'll see here, as a matter of fact, I have people ask me all the time with theplanetstoday.com. There's a couple other planetary bodies out there around Pluto that I don't even know the names of them, but they're about the same size as Pluto. And if we counted Pluto as a planet, we'd have to count all of them. And there's like hundreds of them. So
that makes sense.
Yeah, we had to kind of get rid of Pluto. So I know we're all upset, but anyhow, so this was the image that you see here is showing back in January when I first had, this thought, like, well, where are these things at? Because this is definitely something going on. And like I said, it was actually last summer where I first thought about it. And then I wanted to double check it once everything started popping off again in December, in January. And sure enough, if you see that image there from theplanetstoday.com, look how close Jupiter and Saturn are in relationship to the Earth and the Sun. Mm-hmm. And if we use that same analogy of spring tides and neap tides as we do with the Earth, the Moon, and the Sun, we can look at that, and this almost puts us right into what would be considered a spring tide for, tidal forces in our solar system, where we have the Earth, then we have the huge gravitational mass of the Sun, and then directly across we have Jupiter and Saturn. And I think it has a lot to do with those two planets being so close to each other, where it kind of magnifies that gravitational force. And why it becomes an important factor in what we're talking about, because I think it's those two planets in relationship to each other that gives it just that little bit of extra tug that can cause a little bit of extra tectonic activity. And again, we're in it right now. We are right in the middle of this happening right now. This was back in January in that picture right there. It is important to note, though, that planets don't move around the sun at the same rate. It takes us 365 days to go around the sun. And planets like Saturn take 30 years. 1 year for Saturn is 30 Earth years. And same thing with Jupiter. Jupiter's 12 years. So it takes Jupiter 12 Earth years to go all the way around the sun once. And so that kind of sets up this pattern where we have Jupiter and Saturn close to each other, and Earth is being affected by that, and then they move farther away from each other, and then it's not quite that big of a deal, and then they come back together on the other side of the solar system, and we see this again. And so it sets up this predictable pattern of these tidal forces in our solar system. And if you click on the next slide, we'll actually see where we are today.
Oh, wow.
Okay.
I was telling you because we were texting back and forth, and I saw some meme on, I think, Instagram, and it was saying the last time this planet was in this alignment and this planet was in this line was like 500 years, one was 300 years, and the last time those were in those positions, there was like the French Revolution, the Black Plague, all these weird things. I'm not saying anything in particular, but I just find it weird that that's the case, and here we are.
And I don't think it's weird. I don't think it's that weird. I think that that these things happen and we're just not very aware of it, and it causes conditions to change, and so anyway, so what we see in the picture right here is actually showing almost all of the planets in the solar system bunched together on this side of the sun. This side of the sun, this side of the this time of year. If you actually see, this is today, guys. This is right now. You see, and again, if you're listening to this later, this is June 28th of 2020.
I feel it.
We've got Mercury and Venus. Then we have Earth. Now, keep in mind that right now we're in a neap tide. We're in a first quarter moon phase. Which, remember, the moon is the closest gravitational object, and it affects us probably the most. But it's actually perpendicular to the sun and those other planets and stuff like that. So we're actually kind of in like a, let's take a breather phase. But then right beyond that, you'll see Mars is a little bit out of it. And then you have Jupiter and Saturn back to back. And that really sets up this like alignment of planets. And, I can remember growing up and hearing some woo stuff, about, when the planets align, this kind of stuff happened. And I can't believe that, like in 2020, I'm actually looking at this. I'm like, holy craps.
Well, vibration and gravity. I don't think those two things are given enough. Given enough effort and attention.
No. So anyways, this is today. I really do think, and this, I mentioned this to you earlier, Mike. I hope I'm wrong. This is one of those times where I've put in the research and I just hope I'm wrong. Like, I hope this isn't actually going to pan out and that we make it through to October unscathed.
Right. So when's this window though? Like, how long is the window, do you think?
Well, go to the next slide.
All right.
Yeah, the next slide. The June. What's that? Go back one. Oh no, I'm sorry. Okay, real quick.
We can put a marker on that and go back.
This up. I put this slide in there. This takes us back to June 21st. This is just a few days ago. Now, if you recall, the second slide that I had on this
Oaxaca, the earthquake.
Yeah, the volcanic eruptions and those earthquakes that occurred just in the past, 7-8 days, occurred right around that new moon phase. And so I think that's going to be super important. Again, it's the closest gravitational object that we have to us, which probably affects us the most. And right now we're in like that neap phase. Right now we're in that first quarter where it's perpendicular and it's kind of leveling things out. But now go to the next slide and we'll be in a full moon just in time for.
There we go.
Yeah, we'll be in a full moon just in time for the 4th of July.
The real fireworks.
Yo, baby.
Justin, and it's actually, I think the official full moon date is July 5th, but I couldn't pass up the fireworks. But no, if you see that, again, this is in just a few days, in next week and a half or something like that. We'll see that we will be in a full moon where we still have that alignment between the sun, Venus. Venus is close enough to affect us a little bit, and I think that's important. And then you have the Earth, the moon, Jupiter and Saturn, those big giant gas planets, all in that line. All aligned, and I think we'll see like a little bit of extra strain, a little bit of extra pull, and we could quite possibly see some pretty serious eruptions or earthquakes taking place those days. That and again, I'm not trying to say that the Earth is going to split in half and Yellowstone is going to bubble up and blow up and things like that. But I do think we'll see an increase in volcanic activity, and it could be, it could be a problem. And so if it's true, then this is definitely something that's predictable, and we should definitely plan for it. This is the thing that really, really bothers me right now is all of the stuff that's going on. I don't even want to say the name. I don't want to flag you, on YouTube or anything.
Yeah.
But all this going on right now is causing issues. And if something like this were to happen, where we had a couple of major volcanic eruptions or major earthquakes in some capital cities or something like that, then it could be a big problem.
History Shift is asking if the planets all align. Would this create a pull on magma? So that's kind of a question going back to what I asked you earlier. Would that, and if that's the case, if it does pull the magma, I don't know. I'm going to expound on that. Did you read the recent article on supervolcanoes in southern Idaho and how they're using paleo magnetics to figure out that when the iron was ejected, it rests towards true north? So if there's a bunch of iron wherever it is, would that have more of an effect from the pole or no?
No, usually it's the other way around. Usually it's the iron in the basaltic rock is what you're talking about.
Yeah.
Because it's magma, because it's fluid, the iron aligns itself to the magnetic poles. It actually aligns itself to north and south. And that's one reason why we can actually map like the mid-Atlantic ridge and moving away on both sides of that. And we can map it's because as that magma's bubbling up and it solidifies, all those iron filaments and fragments are lining up with whatever happens to be north at the time. So is that what you were talking about?
Yeah, well, I was just saying with that, if there was more, if there was more of a magnetic pull because of the conditions, would it? No, that wouldn't have any effect on what the substance is under the hot spot or whatever.
I'm not real sure. I'm not exactly sure. I don't think anybody knows exactly what drives hot spots.
Right.
I think it probably has a lot to do with convective currents in the mantle.
Okay.
And again, it's just an area where it kind of gets raw. Kind of like a,
it's getting chafed.
Yeah, exactly.
Whoa, bro.
And then it stays that way for a long time. If you look at like Google Earth and just look at Hawaii, which is a very well-known hotspot, that thing has been erupting in the same spot for a billion years. I don't know how you can actually follow those islands all the way back until they get subducted under the Aleutian Island chain.
Yeah, that's crazy.
Yeah. So this has been going on for a really, really, really long time. And same thing with Yellowstone. Yellowstone. What'd you say? Was there 12? There's like 3 major eruptions, but there's evidence of like 12 of them or something like that.
Well, yeah, the most recent one wasn't even explosive. It was like 170,000 years ago, and it was just a basaltic flow, similar to what you would probably see on the Hawaiian Islands.
And that we'd be lucky if that were to happen.
Yeah, but I think History Shift was just asking because he's nervous because the hot spot started in southern Oregon and worked its way. It's going straight up towards History Shift.
People are starting to get worried.
Yeah. Like I pointed out yesterday, he's actually moving towards it. It's his fault.
That's right.
He's the one. It's the crust moving over the hot spot.
Yeah, that's the craziest thing about all of this is just all the moving parts. It's like a gyroscope within a gyroscope within a. It's all these different things happening at once.
And we're really just starting to understand it. I think we talked last time about. The plate tectonics, the theory of plate tectonics wasn't accepted until like the mid 60s, late 60s. That's in our parents' lifetime. That's not that long ago. And so we're just scratching the surface. There's so much that we could still learn about it. I definitely don't want, and just like what I'm talking about here, these are connecting some dots that most people haven't connected, and it should be looked at. So
yeah.
I think, what History Shift was saying, definitely the time, I think that those gravitational masses can affect magma. And it's the actual, like I said, I think it's like the breaking point almost, where just that little bit of extra tug causes an earthquake, or causes the magma to shift, or something happens just from that little bit of extra tug, and that's why when we start seeing some differences or some eruptions. And again, I'm not trying to say that these are the only times that volcanoes erupted, the only times that earthquakes happen, because we know that that's not true. But I do think that we will see an increase over the next month in some pretty serious, possibly. I don't think I said I hope I'm wrong, but I think we could possibly see a major event in July.
How accepted is this kind of an idea within geology or academia in terms of, is this something that's even thought about? Is this something that or
there
no?
are some papers. If you go to the presentation I have on this on YouTube, I have in the description area, I have some links for papers and things like that discuss this. But really what they're looking at mostly are the gravitational attractions between the moon. They're looking at moon phases and making those connections between that. I'm trying to say that this goes much deeper than that. And it's a solar system,
Sure.
the whole solar system. I also think that this has a lot to do with the sunspot activity that we have on the sun right now. We're in a solar minimum. And we go into these solar minimums, every 11 years, or there's an 11-year cycle, right? So we go from the solar maximum to a minimum in 11 years. Well, if you double that, so you go from solar minimum to solar minimum, it's about 20 years. And when we actually start looking at these planetary alignments, well, guess what happens every 20 years?
Right.
Jupiter and Saturn line up.
Right.
and that's, I looked at it earlier today. We'll look at a couple examples here in a little bit, but, if this is 2020, 2021, back up 20 years, that's the year 2000. There was quite a bit of major volcanic activity, major tectonic activity back in 2000. Mm-hmm. Back up another 20 years. What major event happened in 1980?
Right. Oh, the Mount St. Helens.
Mount St. Helens erupted in 1980, right? You back that up to 1960, and there was, I just kind of experimented and went back in time using theplanetstoday.com and just kind of looked to see what dates we were whenever these things lined up.
Right.
And just would Google, what volcano erupted that year. And every time they brought up this stuff, they brought up different major volcanoes. I went all the way back to the 1700s, and I would type in a date like volcanic eruption this date, and it would come up with the chaos eruption, or it would come up with the I can't remember. There was one in 1862. It was like a day of terror is called. It was a volcanic eruption that occurred, or it was an earthquake that occurred in California right as they were colonizing and stuff. So
right. So
yeah.
And you mentioned the mechanism, or we talked about the mechanism behind the supervolcano being the hot spot and it just melting like a thinner part of the crust or something more vulnerable, whatever material it's made out of. But when you look at what's going on here, do academics see it as like more of a chaotic process, or like something that's not really they're able to keep track of? Is that how it's kind of viewed, or?
Yeah, I think so. I mean, I think so. We'll talk about an example here in a few minutes. And, there's been a rash of activity in a certain part of the world over the past few days, really in the past few weeks. And I was reading an article before we came on where, they were like, well, it'll probably just die down. It's not a big, this is coming from a volcanologist, saying, it's not that big a deal. It'll probably calm down. I'm like, man, I don't know, man. And so we'll talk about that here in just a few minutes, because
Okay.
I do think that there's a disconnect, and there's, they don't want to tie in the cosmos to planetary, tectonic activities. And we should really be paying attention. We should really be paying attention.
Do you think it's for an example, like evolutionary biology, you see most people gravitate towards the phenomenology of it as opposed to the mechanism or like the minutia to figure out what's going on. So you're saying maybe we should, even though that's what maybe they're looking at in geology right now to figure these things out. Maybe we should be looking at it from more of a phenomenology standpoint, kind of reversed in that regard.
Yeah, and actually, that's a good point that you brought up, because what we're talking about right now is actually tied in to evolution.
Right.
And I say that because we would not be here today if it wasn't for the moon and the tides, that we're talking about, these tidal forces between the moon and the Earth, and specifically the oceans. Because
hydrothermal vents.
Yeah, because that's where all life started, right? We have life starting in the oceans, but if there was no reason to get out of the ocean and survive, we wouldn't have evolved into what we are today, or any land animals wouldn't have evolved into what we are today, because it's the tides. It was the tides that caused organisms to become stranded when the tide went out, to form evolutionary advantages, or to have evolutionary advantages that could cause them to survive, to breed, and to pass on their genetics onto the next generation. And a great example of that is, just organisms forming shells. That there would be no reason for an organism to form a shell, like a clam or an oyster or anything like that, if we didn't have tides. So the moon is super important for, evolutionary life on our planet. To even have taken the course that it has. So it does all tie in together. I don't know if that was what you were talking about, but
yeah,
I did find that did find it interesting.
That answered my question. Thank you.
All right. So anyways, July 4th, I think we really, and I'm not just saying like specifically on July 4th, I expect to see something happen that day. But around, that's why I have that like little squiggly line there, around that time, an estimated time where we're going to see just that little extra tug of gravity from these planets that have aligned that could cause a tectonic activity, a volcanic eruption, and an earthquake to occur. Go ahead and click to the next slide, because it's not just now, but that we have to be concerned with. But I mentioned earlier.
History shift real quick. Wanted to know about a possible pole flip, and if that completely takes us out of this, we'll put a pin in that to the end.
Yeah, well, I don't think pole flips really affect us that much. They would affect us, like our civilization, because we've become so used to GPS navigation and things like that. I don't think pole shifts are really that serious as far as life is concerned on the planet. So it's not really something that I think we should.
But they know the pole is moving. I have been following that.
Yeah, but it hasn't been. It doesn't affect us. It's not something that
right.
Be super concerned with. And now there are some. Obviously, I know there's a lot of people out there talking about the ionosphere, and when the poles shift, all of a sudden we don't have this protective shield from rays from the sun and things like that. But yeah, I don't think that's
if that happens, we're screwed. There's nothing you're gonna do anyways. So
I don't even think that's true. Like I said, life moves on. I don't think it's.
So you think we just maybe evolve some sort of UV protecting mechanism within ourselves?
Probably already have. That's the thing.
But if we didn't have that, how much do you think that would affect?
I really don't know. We might see some cool like auroras and stuff. I really don't know.
That would be awesome. Northern daylights.
That'd be cool. Go back one slide real quick, because we weren't quite talking about July.
All right.
Yeah. So we have a full moon coming on the 4th. If we go fast forward, like, a few 15 days or whatever, half a month, it brings us up to July 20th, and that's going to be a new moon. And you can see here, we're even more aligned now with Jupiter and Saturn and the sun. And so I do think that this is going to be, a month-long, thing that we might see. And again, it's not just now. Remember, I started off by saying that I notice this happening like every 6 months, where, there's a rash of activity in the summertime, and then it happened again in December and January. So go ahead and click on the next slide. That takes us to next winter, 6 months from now. And we're still in this like gravitational alignment where we have now we're on the other side of the solar system, but it's still that spring tide, spring tide alignment where we have the Earth, the Moon, the Sun, and those two planets there. So we're kind of stuck in this for a few years.
Yeah.
And every 6 months we'll probably see an increase in activity, and then it'll die down, and then it'll come back, and then eventually it'll kind of calm down where we're just kind of back into normal rotation for about 20 years, and then we see it again. I obviously think that there's more to it. I mentioned a few minutes ago that I think that solar activity has a lot to do with this. And there's all kinds of theories that, about why we're in a solar minimum right now. Why are there no sunspots? And I think it has to do with the alignment of the planets and where they are, and the gravitational pulls that kind of calm down the sun. And it's not until Jupiter and Saturn get far enough away from each other where that cycle picks back up, and we have a bunch of sunspots when now they're in tug of war with each other. And then they come back together. We go back into a solar minimum. Now, I don't know, and I should research this a little bit more, but I don't know why this is a grand solar minimum. And that might be an important part of this. There might be more to it that could make this more dramatic. I don't know.
Yeah, absolutely. Now, do we know though why the hot spots move, or what causes them to move around? Or you said it's obviously us. Are they stationary and the crust is just moving over it?
Yep. The hot spots don't move. It's the crust moving over the hot spots.
Okay.
And that's an important.
That's the centimeter per year. That's why it's taken so long of time for. Even though it's moved from southern Washington, the Yellowstone hotspot from southern Washington to the corner of Wyoming, it's actually the crust moving over the hotspot towards where Oregon is.
Yep.
Okay.
And now, why those hotspots are there? Like I said, that's still anybody's guess. I'm not exactly sure on why that is.
Could it be like a missing part of the whatchamacallit, like the outer core or something where there's like a missing gap of material there, something like that?
Yeah, I've heard of that too. Like I said, there's a couple hypotheses. I kind of lean more towards the fact, that there's like some kind of convection current that causes that to be, again, like I said, like kind of raw, like it's just kind of like heating it up in that area. Again, I don't know why that would last for millions and millions and millions of years.
Right.
I've heard of people say that they could be impacts, and at one time there was a big punch right to the planet, and that's what caused that raw spot, and so
that would make sense too.
Yeah, and again, I don't think there's enough, and the crust moves, through plate tectonics, so all that evidence would move with it and get subducted later on, and so anything that would have given us a clue to that is, sucked under, like for Hawaii, for instance, it would be underneath the Aleutian Islands, turned back into magma. And that's just how plate tectonics works. It just is recycling that material all the time. So I don't know. That's again, those hot spots are really kind of they're really cool.
Yeah.
I've been to Hawaii, I've been to Yellowstone, and it's really cool to see that.
I know I want to really get out to Yellowstone before this whole thing goes under.
Yeah. So anyways, let's see. Click to the next slide. I think we're going to wrap it up soon.
Yeah, we're on slide 13 out of 14.
Yeah. Okay, so I'm going to take it one step further. If I'm already gone on the edge here to kind of make a prediction back in January that we're going to see some stuff go down in June, I might as well take it one step further. And I really think that we're going to see a pretty major eruption in the Iceland area. Like I said, I'm really kind of going out on the ledge here, but there has been quite a bit of tectonic activity over the past few days, over the past month. If you look on, I'm not even going to attempt to say these names of volcanoes that are in Iceland.
Yeah, I'm pretty good with names, and I don't even want to attempt those.
No. But if you look in those graphs on the bottom, the one that's on the left shows us seismic activity over the past years, over the past 6 months. So it goes back to January.
Wow, it's really heating up at the end there.
Yeah, you can see how like back in January we had a bunch of activity, and then you were talking, where we had in March we had some activity, and then it kind of died down and it stayed kind of level until we hit June.
Mm-hmm.
And again, I think this has to do with those gravitational alignments of those planets getting closer together, and us getting closer together to being aligned with them. And so the chart on the right is really just in the past 30 days. This is just this month. And we had a whole bunch of activity. And if you notice the date there, that was June. What's that? Was it 21st? So this, I can't see it.
I can't. It's very faint. I can't see it either.
I want to say that this is over the past week. And so we have like June 21st, which was the most recent new moon. We had a big rash of not volcanic, but there were earthquakes, really minor earthquakes and tremors and things like that. Each one of those circles represents a tremor or an earthquake. And so you can see there's just hundreds and hundreds and hundreds. I think I saw an article that said there was like 3,000 like little tremors and earthquakes in Iceland over the past month. That's a lot.
Right,
there's something out there underneath that. And then you can see it kind of tapering off, but that was during the time where the moon was more perpendicular to the earth and the sun. And so I think that as we get into the full moon phase on, July 4th, we're going to start to see an increase in volcanic activities. It'll be interesting anyways to see what happens. Like I said, I've never been more hopeful that I'm wrong about something ever. But it will definitely be interesting to keep an eye on things over the next few weeks as we move through July and into August.
Yeah, I think it's interesting. Like I said, there at one point, at the beginning of the summer, I think there was like 30 volcanoes erupting all at once or something like that. So it makes sense what you're talking about. Is that the case? I mean, who really knows? It needs to be looked at more, this kind of stuff. Like you said, more from like a phenomenological. I can't even speak right now. From a phenomenology standpoint.
Yeah. And actually, I talk about that in my YouTube video. I'm like, there's all the data's there. Just it takes people I don't have the time for that, but it takes people, a grad student somewhere who's like, I need a PhD project. This is volcanism 101. Go through the dates, and every 20 years you're going to see a spike in volcanic activity as we're going through this, and all these major events, like I mentioned earlier with Mount St. Helens. That was a big time event that happened right during one of these alignments, and we can just keep going back and back. I kept coming across tsunami data and things like that. If you have a tsunami, you have major earthquakes. And every time I plugged in a date and just looked up earthquakes, it came back with some catastrophic, Do
you think
event.
Tsunami too is affected? So if there's like a full moon or something like that mixed with like the earthquake that causes the tsunami, that it makes it more intense or something along those lines?
Yeah, I mean, it's exactly what we're talking about. That full moon is I think it just gives it that extra push,
okay.
Right? Like these volcanic eruptions are going to happen. They happen anyways. Earthquakes happen. They happen anyways. But it's that little extra push of that tectonic, strain or pull that can cause it to be just a little bit worse, or more of them. That's the thing. It's like, I don't know how to quantify it, but.
Right. Now, what about I wanted to ask about the Ring of Fire too. So that's where it's like an outline from the Pacific to Indonesia and Asia and all the way up towards the Arctic. Is when you look at that whole area, is it because it's in the ocean and there's not really a lot of land mass? So maybe that's where the shelves are, is that where all the stuff's happening? Is there a reason why that's there though, like in that specific spot or?
Yeah. The Pacific plate is mostly oceanic crust. And oceanic crust is, because it's like covered in ocean, it's actually thinner, but it's also much more dense than continental crust. If you look at continental crust, you kind of imagine it being the same amount of material, but because there's no ocean on it, just kind of puffs up. And if you actually, if you just look at the slide there, you'll see some of those volcanoes. It's just that's continental crust being pushed up. And actually, what's happening? All of these volcanoes right here are stratovolcanoes. And just like most of all of the ones that are around the Ring of Fire, which is actually a horseshoe shaped. I don't know why.
It's not. It doesn't even close. But yeah, you're right.
We'll talk to Johnny Cash about it.
No, I'll let it slide. But anyways, almost all the way around the Ring of Fire, we have subduction zones. And that's where the continental crust is being pushed under continental crust. Did I say that right?
Yeah.
Oceanic crust is being pushed under continental crust at subduction zones. And as that oceanic crust is being pulled or pushed down into the crust, into the lithosphere, it's getting superheated because of the mantle. The mantle's down there, so it's getting superheated. And that causes once you heat molten rock, it becomes less dense. And because it's less dense, it's going to start to rise. And so you take all this oceanic crust. This is going to make it really, really soupy magma. It makes it makes it very explosive magma.
Yeah.
Because you're also pulling down like ocean water. You're pulling down, decayed sediment and things like that have been on the bottom of the ocean for millions of years. And it's all being pulled down into those subduction zones with it. And as it gets superheated, it starts to rise. And the more you have and the less dense it is, the faster it rises until eventually it reaches the surface and just blows its top. And so that's why all of these volcanoes are what we call stratovolcanoes or composite volcanoes. And they're very explosive. I mean, when they erupt, they just blow their top, and tons of ash and magma gets flung everywhere.
Yeah, there's a few different types, right, of magma. I mean, like from what I did when I did the research for that supervolcano episode, from what I understand, it's rhyolite is the explosive kind because there's silica mixed in there with the basalt, and with the super runny stuff like the Hawaii stuff, that's just basalt and something else I forget.
Yeah, and it has a lot to do with where that magma is being formed. Like you said, the rhyolite is being formed underneath those subduction zones where you have all kinds of junk happening.
Yeah.
But where you have like just that straight.
And gases too. That's what makes it explosive.
Yeah, well, and that's what I mean. Like that ocean water that's being pulled under there, that helps it. That makes it much more explosive.
Right.
But then when you have like splits in, at divergent plates, a divergent place where you have two plates that are moving away from each other, like we find along the mid-continental ridge or the mid-Atlantic ridge. I'm sorry. That's going to form those really basaltic igneous rocks. It's very high in silica, I think.
Yeah.
I think it's silica, and it makes it really runny, and it just kind of oozes out, and it's not very explosive. And so, and that's going to form that really dark basaltic rock, like what Hawaii is made of.
Mm-hmm. Is this one more question, and then we'll let you get out of here, or we got one more slide. I don't know if there's anything on it, but
I think it's the thank you slide. I think.
Okay.
Click it and let's see. I can't remember what I put on here.
Oh, it's just nice. Thank you, everyone.
It's our call card.
Check out. We'll give him a shout out now. Check out Chris's YouTube channel at youtube.com/c/dabblersden, and he's got a lot of good stuff on there. Carolina Bays, younger Dryas, all that kind of stuff.
Yeah. I actually, Maurice, I've been enjoying your hiking videos. Nice. I can tell that you've been stuck inside for a while. You haven't put one out in a little bit.
Go ahead.
They remind me a lot of why I started the Dabbler's Den to begin with. I did a lot of hiking with my daughter and things like that. That was the reason I started the Dabbler's Den. It had nothing to do with science content. It just kind of morphed into that. But
Sweet, yeah, I'm glad you're enjoying those. I went out there. I just shot a bunch of film. I didn't even know what I was going to do with it. And then I came home and I had like 60 hours of footage. I was like, I got to do something with this stuff.
No. Yeah, I was going to say that there's probably places that you go to all the time that all the rest of us would find interesting. So keep it up.
Thanks, man. I appreciate it.
What about?
What was your question?
No, just what's up with the old? So we did one on the super volcano that interests me. I was always curious if that's even a possibility. But what about the old myth with California and the San Andreas Fault, or the fault line cracking and California falling off? Is that even? I mean, that is near the Ring of Fire and subduction zones. Is that even a possibility, or?
It is because that portion. Okay, so that fault line, San Andreas fault line, what's to the west of the fault line is on the Pacific plate. Like that's actually a whole nother plate than what we find on the east side of that fault line. So we have the North American plate and we have the Pacific plate, and because they're actually, that's a transform plate boundary where they're sliding past one another. And that's why we have so many earthquakes that happen along the San Andreas fault line, but very, very slowly. And you mentioned this earlier, like 1 centimeter every, so often. Yeah. I always use the analogy of like your fingernails growing. These plates move at about that constant rate.
Yeah, it's like 1 to 4 centimeters a year or something small.
Yeah, but it's not a constant rate. It's when you're talking about rocks moving past each other, it's not a smooth process. You've got huge chunks of stone, and they get hung up and then they release. And when it happens, we have these like big earthquakes, and that's why the San Andreas is so known for their big earthquakes. But over time, that very, I guess, western part of California, that's part of the other crust, or part of the other plate, will slowly move to the north. Nothing that we need to be concerned with, other than the fact that it is moving, and we definitely don't want to, put all of our resources on top of it.
Sure, absolutely. Yeah, I was just curious. I've never heard anything realistic on whether that's even a possibility. It's just a lot of people. Same thing with Yellowstone. There's an earthquake. People are like, "Oh, it's gonna blow." And anytime there's an earthquake in California, you see everybody tweet, "Oh, we're still here. We didn't fall off in the ocean."
No, it will, but I don't think it's going to be part of anything that we have to do with right now. It's we will never see it.
Well, this was awesome. Thank you for coming back on, and I assume if anything crazy happens, we'll definitely have you get back on as in the future. Check out Chris's YouTube channel again. I'll plug it one more time. Dabbler's Den, and again, he's got a lot of great stuff similar to what we just talked about, as well as other topics. Is there anything else you want to plug?
No. I think we covered it all. Like I said, with everything that's going on the planet today, I've slowed down a lot with what I've been doing. So it's actually good to get out and talk about it with you guys. So I appreciate it.
Yeah, of course. You're welcome on the show anytime. And you're a wealth of knowledge with this stuff, and you have a degree and you know what you're talking about. So that also helps the situation. And it's fun to ask people questions that know what they're talking about. I mean, who doesn't? So.
Right. Yeah, well, let me know as you get into the part 2 of Yellowstone if you need a hand with anything.
Yeah, I think we're going to be doing part 2 is going to be about a lot of the other lesser known supervolcanoes, and then I was thinking somebody sent a message saying, talk about like the, the impact kind of on similar stuff like this, like does planetary alignments and possible comet and asteroid impacts and those kinds of things affecting that as well. So maybe I will reach out to you to ask you a few things on that.
We're part of a cosmic ecosystem.
Yeah.
Take out of all of this.
We better get it all in before the 4th.
Yep.
Watch out.
Shout out to History Shift. Thank you for watching, bro. And shout out to Brothers of the Serpent. Check them out if you like this kind of stuff. This is a majority of the topics that they talk about is similar to this. And check out our website, mindescapepodcast.com. And you can check us out on Patreon at patreon.com/mindescapepodcast. And for $2 a month, you will get exclusive content. So... And if you're watching this, please subscribe, give us a nice review. We love everybody. Stay safe, and we'll catch you next time. Peace.
Cheers.